Previous topics we have learned that Vz design velocity design velocity of a wind design velocity of wind that I am taking the codal reference. Vz is the design wind speed. Vz is the design wind speed. Vz is the design wind speed, and Vb is equal to basic wind speed of 50 years. There are some factors are multiplying with this, the k1, k2, k3, k4, and uh, we are explaining these four factors respectively in the previous videos, and that's why I am again repeating these factors for calculating the design wind speed. So design wind speed Vz is equal to Vb into K1, K2, K3, K4. Vb is the basic wind speed, K1 is the probability coefficient, risk coefficient, and K2 is the terrain roughness height factors, K3 is the topographical factor, K4 is the importance factor for the cyclonic region. So already we have discussed K1, K2, K3, and the remaining factors is K4, and the K4 is the importance factor for cyclonic region. The east coast of India is repeatedly relatively more vulnerable for occurrence of severe cyclones. The east coasts such as Visakhapatnam, the east coast part of the of India, and Gujarat is vulnerable to severe cyclones, and that's why studies of wind speed and damage to building and structure point to the fact that the speeds given in the basic wind speed map are often exceeded during the cyclones. The effect of cyclonic storm is largely felt in the belt of approximately 60-kilometer width at the coast. In order to ensure the better safety of the structure in the region, the following K4 factors as recommended by IS 15498 are stipulated as applicable according to the importance of the structure. The structure of the post cyclone importance is equal to post cyclone importance for emergency services such as cyclone shelter, hospital, schools, communication center. K4 is taken as 1.30, industrial structure 1.50, and all other structure is 1. There is nothing to explain more. Um, Now you can see that the K in IS code the cyclonic factor of K4 guidelines, we can see that we can say that they are separately taking the factors and explaining it, and it is seen that there is Campbell distribution is used. We have learned in our PTech. And for modeling the cyclonic speeds accordingly, the cyclonic factor K4 is defined as the ratio of three gas cyclonic wind speed of mean probable design life to the three gas non-cyclonic wind speed. So the dust curve with conversion factor of 1.2 is used for converting 3 mm wind speed to the 3 mm gas wind speed equation for determining the cyclonic factor. We have very known about this formula, and here they are in explaining it properly. So you can go through this code for more explanation, and consequence of failures and impedance factors, you can go through this part also. So comparison with the present study, you can go through this chapter part for more clarification. And now come to the main part. The hourly mean speed at a height of each of different terrains is calculated by VZH, K2I. K2 is the terrain category factor. You can easily remember the value. You can easily remember the factors. And here I is actually the terrain category. The hourly mean speed of K2I is equal to, there is some formula explained it, 0.1423. I am just putting the formula for in case of category 1, what will be the value. In case of category 1, we already knows Z01 is equal to 0.002. I am just putting this value here. I'm just putting the value here and the design hourly speed k2y. And now the turbulence velocity z1, the turbulence velocity variation with height for different terrain can be obtained by using this formula, terrain category 1. So for terrain category 4, and now by this way we can formulate these formulas also. I am explaining a little bit because there is nothing, no brain is used in this case. Only some formulations we can apply. If there is any doubts, you can go to the comment sections, and if you ask me the questions, I will try to answer this. And now the wind pressure forces on the building or structure. The wind load on a building can be calculated as a building as a whole or individual structure wind pressure. How to calculate the wind pressure? The wind load of a building can be calculated by some factors. Either we can calculate as a whole, or either we can individual structure or individual cladding unit including the glazing and fixing. Design wind pressure, we know that the Pz is equal to 0.6 Vz square, wind pressure Newton per millimeter square Bz. And now you can see this. The Vz is meter per second. Vz is meter per second. Okay. And Pz is Newton per meter square. Vz is meter per second. So this is the point this point is we should mention that the Pd value shall not be less than 0.90 Pz, and with this formula we have to apply three other factors, Kd, K1 and Kc. Kd is the wind directionality factor, K is the area averaging factor, and Kc is the combination factors. Now we are explaining orderly. Wind directionality factor, considering the randomness of the directionality of the wind and recognize the fact that the pressure on the force coefficient are determined for specific wind directions. It is specified that the building or solid science or open science lattice framework and trussed towers has a factor of 0. Lattice framework or truss structure, triangular, square, rectangular, a factor of KD is equal to 0.90 for lattice structure and truss structure, and for circular, and 1.0 for circular structure. And for cyclone affected region, K4, and also a cyclonic region, used for cyclonic region, we generally taken 1. Cyclonic KD is taken as 1.0. And now area averaging factor K. Wind directionality, we have recently discussed KD, and K area averaging factor. Pressure coefficient as a result of averaging the measured value of a given area as the area become larger. As the area become larger, the correlation of the measured value decreases, and vice versa. The decrease in the pressure due to larger areas may be taken into account. The area is less, the area averaging factor is more. The area is more, area averaging factor is going down. The linear interpolation is taken, smaller area, the area averaging factor will be more effect due to turbulence and eddies. Pressure decreases due to the large area. Now we don't know what is the difference between the lattice structures and truss structure. General term of structure made from interconnected bars, rods, angles forming open network or a grid. Truss structure, specific category of tall vertical lattice framework used to support load and height, transmission tower, radio mast and water tank supports. Geometry can be flat and curved, and 2D grids includes bridges, facades and trestles. vertically oriented, often tapering, wider at the base, narrow at the top, and designed for elevation and stability. Purpose used for both horizontal and vertical load distribution, providing strength and stiffness with less material. Main function is to provide height for utility attachment, antennas, cables, etc. Designed for wind, dead load, and live load resistance. Wind design focus area exposed to the wind and shielding effect is the keys. We will learn about the solidity ratio and shielding factor lately. And wind pressure coefficient depends upon the member spacing, shielding shape, and dynamic wind effect, vortex shielding, and galloping. Examples: bridge truss, roof lattice, wall bracing, and frame span brackets, power transmission tower, telecom mast, lighting tower, observation towers. And now we have learned the wind directional factor, area averaging factor, but there is the term is tributary. We don't know, there is some confusion happens in about the tributary areas. So what is the tributary area? Area of the individual member, that means the area contribution on the pressure, the total surface area, roof truss, etc. And this area is actually taking the load, that means it actually taken part in the wind load calculation, design calculation. Tributary area center to center distance between the frames and area of individual member. Tributary area is actually the frame spacing and the panel dimension. Suppose there is a framework and this is the bay, this is the bay, that means frame to frame distance, and b is the panel width. The frame spacing, if the panel width is 2 meter, if the panel width is 2 meter and the panel width is 2 meter and the frame spacing is 6 meter, then we can get the tributary area. That means we get the tributary area of 6 by 2. But there is some more explanation needed to calculate the actual area. And for individual members, suppose there is a roof truss structure, as we can see, and this is the purlins, this is the purlins, this is the purlins, this is the purlins, and this is the rafters, and the tributary spacing of purlins and purlin span. The spacing of purlins, we can take a plan view of this, and suppose this purlin is 7 meter and this purlin is 5 meter, and the purlin, this is the purlin 1 and purlin 2 and purlin 3, and and the this is the purlin actually, this is the purlin actually, purlins, 3 purlins, and the spacing between it is 1.5 meter and 1.5 meter. The average area is equal to 7.6 meter, average width, average depth, and the spacing is 1.5 meter. Then the individual tributary area is 8 meter square.